Dear members, to commemorate the World Science Day, which falls on 20th of Feb, we have amongst us a very special guest, Dr. Daisy Joseph. Dr. Daisy Joseph is a scientist from BRC, Mumbai. She obtained her PhD in physics from the university in 2006. The topic of her PhD was the study of X-ray spectra by photon, proton, and heavy ion excitation. She has guided several PhD students from India. She has represented BRC India in many conferences in various parts of the world, that is Spain, Italy, New Zealand, Sharjah, etc. She is a collaborator for many universities, that is the Mumbai University, BITS Pilani, Rajasthan, Anna University, Chennai, Karnataka University, etc. Dr. Daisy Joseph has many publications to her credit, more than 100 publications to mention, in peer-reviewed journals in her field. She is an active member of the BRC Swachh Monitoring Committee, which takes care of the cosmetic maintenance and clearance of BRC. She is a Vice President of the BRC Officers Association. Dr. Daisy Joseph is a life member of Borli Malayali Samajam since 2000 and has rendered many songs in various BMS events. We feel very honored and proud to have Dr. Daisy Joseph as a member to the number of achievements that she has acclaimed nationally and internationally. Our best wishes and prayers will always remain with you in your future endowments. Now we welcome Dr. Daisy Joseph to enlighten us with a very useful and informative lecture. Thank you.
Hello children. Today we are here on a special occasion to commemorate the birthday of Dr. C.V. Raman, which is on 28th February. Hence, 28th February is also observed as a Science Day. And for this occasion, I am here to give you a lecture on metal levels, which is trace elements in nutrition and its consequences in human health and diseases. I will make myself very simple so that the topic looks very interesting and very exciting for you little children, and you have the motivation to pursue science. Now let's get started with the lecture, which is metal levels, trace elements in nutrition and its consequences in human health and diseases. I am Dr. Daisy Joseph from the Nuclear Physics Division of BARC. I have been working in BRC as a scientist for the past 34 years. I have pursued my PhD in physics in the field which I am working, and I am in the global field in this spectrum of science. And I really enjoy my work and also would invite students to visit BRC and have a collaboration with my project and with my work. I will welcome you all, with especially those students who would like to pursue science with full of passion. So what are exactly trace elements? Trace elements are the essential elements found in traces. Why traces? Because it's ppm, that is parts per million in the universe, and can be categorized as. These are the elements which are found in the body, which are essential. Also, they could be toxic above a certain limit. Essential are the nutritional elements which are required for the essential function of the body, and toxic elements are those which have a negative effect on the human health. In my coming slides, I will show you, I will categorize the elements which are essential for the body and the ones which do have a very negative effect on the body and which puts us to disease. I will also include the present COVID-19, which is affecting everybody's health and hence is a concern for the global people around. So, trace elements are the elements in the periodic table which exists in traces. As I told you, it is ppm. ppm meaning parts per million. microgram per gram. They can be categorized as macronutrients. Calcium, potassium, sodium, magnesium, phosphorus, chlorine. I hope you all are familiar with the periodic table, and if you go to the periodic table, these are the elements, the low Z elements. Z is atomic number and they all fall in the low Z category. Micronutrients such as iron, copper, nickel, zinc, rubidium, strontium, selenium and bromine. These are the elements. They are also low Z, but they are essential. Essential, like iron is the most abundant element in the universe. Copper, nickel, they are essential for the enzymes and the basic functional requirements for the body. So the essential elements for warm-blooded animals are fluorine, silicon, vanadium, chromium, manganese, Fe, cobalt, nickel, copper, zinc, selenium, arsenic, molybdenum, tin and iodine. And in universe, the element which is abundantly found are Fe, copper and zinc. And the bulk of living matter consists of 11 elements which do also have a low atomic weight, such as hydrogen, carbon, oxygen, sodium, magnesium, phosphorus, sulfur, chlorine, potassium and calcium. So I have a setup or a technique in BRC which can detect all these trace elements in any sample, be it biological, be it material science, be it geological, metallurgical. I will show you all the applications which I have carried out in the course of my career, where the different universities and colleges collaborate with me and they get their problems solved using my technique. So here is the basic principle of how we detect the trace elements. In this, if there is a photon, I hope you know what is photon. Photon is a gamma particle, and which is ejected because there is an excitation source and that strikes a sample. Photon is electron is ejected and goes to the ground state, and subsequent transition is there from the higher level to the ground state. In this transition, you get the a characteristic X-ray which is ejected, and that characteristic is seen in the detector and it is seen as representing the element. Which element? The element, it is called characteristic because it is characteristic of that particular element which has discrete electrons surrounding the shells around the nucleus. So these shells have certain electrons, and hence it is characterized by that element, and that element can be detected using a detector. I will show you the setup. Now this process of X-ray emission I will explain. Photon is ejected from a radioisotope source, falls on a target. Electron is ejected from its innermost shell. The energy of the photon must be greater than the energy which the electron is bound to the nucleus. Hence, then only it can be ejected. Now, when this is ejected, an electron from the higher level is transferred to the lower level, and during this transition, photon is emitted from the atom. This light is called characteristic X-ray. Now, the energy of the emitted photon will be equal to the difference in the energy of the two orbitals occupied by the electron making the transition. Because of this energy difference between two orbital shells, which is characteristic of that particular element, the photon emitted when an electron moves between these two levels will always have the same energy. And hence, by determining the energy, which is also could also be wavelength, which is wavelength is reciprocal of energy of the X-ray, one can detect the identity of the element or the energy of the element, which is the characteristic X-ray. Now, what is X-ray? X-ray fluorescence. This is my field, and I have been working in this field for the past 34 years, I am an expert in X-ray fluorescence and can be applied to many applications. In fact, almost all applications where trace elements detection is essential for proceeding any experimental work. It is an analytical method, analytical meaning a diagnostic tool to determine the chemical composition or elemental analysis of all kinds of materials which can be in solid, liquid, powder, filtered, slurry, paste or other forms. By identifying the energies of the radiation emitted by the sample, it is possible to determine which elements are present, hence qualitative. And by measuring the intensities of the emitted energies, we can measure the quantitative analysis of that means how much of the element is present. Now, there are some advantages for this technique. Advantages such as simple spectra, spectral are almost independent of chemical state, they are minimum sample preparation, and application is wide range of concentration from ppm to percentage, and it has good precision and accuracy. Before we go into this, we should know where X-ray lies in the electromagnetic spectrum. X-rays, if you observe, it is between 0.125 kV to 125. It is just below gamma rays, and here you have the ultraviolet, then you have the visible light. So, it is electromagnetic wave which can be called associated with wavelength, and also the wavelengths are between gamma ray and ultraviolet, and these wavelengths are from 0.01 nanometer to 10 nanometer, corresponds to energy of 0.125 to 125 energy. So, this is my setup. Here we have the sample. Here we have the radioisotope source, which is a ring source. Its photons are ejected falling on the sample. What comes out is the characteristic X-ray, which is again a photon falling on the window of the detector, and here you have the semiconductor detector, which is connected to a high voltage power supply and also a preamplifier. This is to give a negative supply, negative bias, and then you ultimately amplify the signal and you get the spectrum in a PC based multi-channel analyzer, where then you do the offline analysis after it is stored in the spectrum. Next. So, I will explain to you some of the radioisotope sources which are there in our lab, and I have been using it for the past so many years. You have Fe55, which has a half-life of 2.7 years, and it gives 5.9 kV. So, any element which has an energy below this can be detected, and its yield is 28.5%. You also have, this is for the low Z, this is a medium Z, and this is for the high Z. So, these are some of the radioisotope sources which I am using regularly. And if you see the spectrum, in the geometry, you have a ring source here, the target is placed exactly opposite, and again you have a point source here, target is placed exactly opposite. Then you have a side source geometry, and the point source is placed at the side so that you get a better efficiency. Papers have been work has been carried out based on this on rare earths, and we have a very beautiful paper talking about the sensitivity, comparing the annular geometry and the side source geometry. Again, we can go to this very big technique in which instead of photons you use protons. Protons are used, the process of X-ray emission is almost the same, but protons have a better flux because they give 10 raised to 12 atoms per second, and here the ions are ejected, the hydrogen ions, they pass through a magnetic magnet here, bending magnet, and goes up to to the dome of the Van de Graaff accelerator, and here the negative ions are stripped and you get a positive ion beam which comes down and bends here, and again it goes to the beam lines, and here you have the PIXE chamber in which I do the analysis. Our samples are introduced and we have the same setup, and it is detected using a SILE detector, semiconductor detector. This is a lateral view of the same setup in which in the chamber you have the samples mounted and you have a detector, and this setup is the same of what I showed you before. So this is a photograph of the detector, and the front part is inserted into the chamber. Here the samples are taken using a ladder and mounted in line with the beam where the proton beam comes, and one can analyze the sample. So now let us go to the main topic of what we were talking about, trace elements in the human health. So if you see, these are the elements in blank that form the bulk: hydrogen, carbon, nitrogen, oxygen. They form the bulk: sodium, magnesium. And the dotted ones, they are essential trace elements. So you see these elements, and if one is familiar with the periodic table, it is very easy to identify that these elements are the lower Z elements, but they are the essential elements. So if you see this, blood, copper and iron in various clinical conditions in man, this is microgram per percentage, plasma copper and Fe. For normal you have this figure, pregnancy you have still higher, and if you see iron, you observe the values: infection, acute leukemia, chronic leukemia, Hodgkin's disease, anemia again, all these diseases, you see the values are slightly on the lower side. Copper contents of normal adult tissue. Now these are the copper contents, this should be the range, 20 to 50 milligram per kilogram. Brain, 20 to 40 milligram per. These are the observed values. Why? If there is a difference in any of these values, it assumes that the person is in a very clinical or bad condition, and it needs to be tested for that. Now, as we have seen these trace elements, we should also see what is toxic elements. Toxic elements, all these elements are included: arsenic, antimony, barium, beryllium, boron, cadmium, chromium, copper. Chromium only is the oxidation state of 6 is toxic, not the 3. Copper, lead, lithium, mercury, molybdenum, nickel, selenium, tin, vanadium, zinc. These are toxic elements. Zinc is also after a certain level, which I will show you. Now, let us see the effects of these elements on human beings and plants. Let us go one by one. Arsenic. Arsenic is toxic in most of its chemical state. Diseases such as skin cancer and lung tumors result from inhalation of arsenic, and the allowed concentration is 2 microgram per meter cube. So many times people suffer a lot of asthma and other lung diseases because of inhalation of arsenic in the air. That's why pollution of the air is very harmful, and what we inhale in the air and also through food is important. Antimony. Antimony exposure to dust containing antimony can cause irritation of nasal passage, eyes and lungs. As little as 97 milligram is considered toxic. Barium accumulates in the lungs, giving rise to lung disease. It is highly toxic when ingested and can cause convulsions, stomach, intestines and kidneys, hemorrhage. Limit is 70 milligram per milligram. Beryllium. Beryllium compounds are known to be toxic both in soluble and insoluble forms. Soluble compounds produce acute pneumonitis. Insoluble compounds produce chronic pulmonary diseases known as berylliosis. Limit is 0.5 milligram per milligram. Highly dangerous element. Boron. Boron has a low order of toxicity. Cadmium, prolonged exposure to airborne cadmium frequently cause kidney damage resulting in proteinuria. Every cigarette has 1 to 2 microgram cadmium. That is why cigarette smoking is discouraged. In drinking water, concentration of cadmium should be less than 0.01 ppm. This is some of the elemental composition of human milk. We all consume milk and we really do not know what is added in the milk when it at last comes to us for consumption. But it should be noted that some of the range of concentration, that is microgram per kilogram, should be all these numbers for all these elements, essential elements, and all these essential elements. I do not want to read them, but one can have a look at this range of concentration. Next. Now, essential elements, trace elements in man. This is silicon and required is 260. One can take 3 milligram. Remaining elements are all essential and these are the daily intake. Next. Now some of the applications I have carried out using this technique is study of blood lead levels in children from the Dharavi slums of Mumbai by PIXE from Van de Graaff. Why have we selected children from Dharavi? Because they are the ones who inhale a lot of lead which comes out from the vehicular exhaust of the traffic that passes by in and out almost the whole day. And these children, they directly do not inhale, they could be, but they were admitted to KEM hospital and the doctors had a collaborated study using this technique of ours, telling that the children are highly anemic. The first symptom of lead poisoning is being anemic. And anemic, lower Fe, higher lead. And there are different categories of anemia in which pica is a category where the children eat the mud or the dust which is around the place, and that dust is very dangerous as it contains a large amount of lead, and hence they end up getting anemia, and anemia can lead to mental retardation and consequently it is considered dangerous. Next. So this is what the spectrum in which we have seen. These are the counts and these are the channel numbers which can be converted using calibration, energy calibration into energy. And here you see the lead X-rays, lead alpha, lead L beta, which is 10.5 keV, 12.6 keV, and generally L X-rays has 3 components, L gamma also, which I have not marked. The others have K components, which is K alpha, K beta. Besides all these elements you see a large amount of lead also. Next. So if you see I don't know if it is visible, if you see there are different categories of anemia: hypercrossic microcyte anemia, gastrointestinal symptology. These are the different symptoms. They can be grouped into, and if you see the last value, the column, the lead is shown 0.1. This is all microgram per gram, that is ppm. But if, let us go to the next slide. Okay, here you see the mental retardation, and here see the average is considered 1.5, and international average for controls, that means a person without diseases 0.3, that's sort 0.3, and international is considered 0.2, but all have shown above that, which is, that means they have a high lead values. Next. So it was concluded that lead is considered very dangerous for the children especially. This is, I carried out some trace elements in tea and soil samples, and these were the elements, and these are the in soil what we see, they are all in ppm, microgram per gram, the soil elements and the tea leaf elements. Next. Now, I also detected mercury and heavy metals in Ayurvedic medicines by ED-XRF, that is energy dispersive X-ray fluorescence. Now, it is recommended that Ayurveda is considered to be very good for the body and it is considered to be a good healing medicine. However, they do use heavy metals such as mercury to process the sample, and it is concluded, or a clinical study has found, that this heavy metal should be excreted out of the body. Hence, they observe diet regulation while taking Ayurvedic medicines. Hence, we have seen mercury L alpha, L beta at a very high value. If you see the counts and the channel number, which is again actually corresponds to the energy, you see the 3 peaks of mercury. Next. So, these were some of the medicines, Balguti, Kesaria, Yograj, Gugal. I do not want to read all of them, but they are the different manufacturers' description of the herbal medicine. Next. So, if you see the table of these trace elements, here you see arsenic, a bit of has been cut off, you see 257 for arsenic, which is quite high, and again you see mercury, which is showing in some very high values of ppm. Next. So, the conclusion is that Ayurvedic drugs contain heavy metals. They are administered to children and newborn babies. So, it points out that they should be tested for content of heavy metals, and more comprehensive clinical studies are required to assess whether these heavy metals do have a very bad effect on the children, and it should be removed from the body, especially the heavy metals. After it is ingested, the blood should be checked for the heavy metal content. This is again, it was published in International Journal of PIXE. Next. So, these are some of the spectrum of soil sample, and this is of leaf sample, which I showed you before. Here you have a large amount of zinc, yttrium, rubidium, Fe, copper, titanium. Next. Now, the application of such a technique is far and wide, that you can use it as a diagnostic tool for detecting trace elements in any field of applications like leaves, soil, hair, teeth, bones. They are all indicators of the general health of your body, your fluid of the body like the sweat, the urine, the blood serum. They are all indicators of how your health condition is. Next. Now, I have also applied my technique to the study of uptake of uranium by cyanobacteria using ED-XRF, meaning it is a field of study called bioremediation, in which uranium around the reactors can be removed or absorbed by cyanobacterial cells. Also algae cells is a natural way of removing, and hence they do not require very big equipments, and it saves the atmosphere and nature from uranium toxicity. So, we in collaboration with molecular biology division, bacterial cells were grown in uranyl nitrate and carbonate, and they were determined for uranium content using my technique. They found that other than these elements, uranium was also present. They were present and significant after 2 hours of uptake, and it became saturated in 5 hours, after which uptake reduced and became minimum. So, in 5 hours all the uranium was absorbed. This was the most cited paper in my list of publications. Next. So, here you see the spectrum in which in addition to Fe, you also have uranium L alpha, L beta peaks, which shows that the uranium was absorbed at 2 hours, and at 5 hours it became minimum or saturated. Next. So, now let us go to the COVID, which is a very trending and very dangerous disease. what is seen is malnutrition and electrolyte imbalance can make dysfunction in the immune system. The basic thing is, you no doubt cover your mouth and nose with mask, but what is more important is your immune system should be strong. How is that your immune system? If there is a dysfunction, if there is a malnutrition and there is an imbalance, your immune system is going to get affected, increasing risk of infection. So, vitamins including A, B, C, D, E and folate and trace elements including iron, zinc, magnesium, selenium and copper have important roles in supporting this immune system. You want to increase your immune system, basic elements such as iron, copper, zinc, magnesium should be taken in proper amounts regularly, and that is why the herbs which they say curcumin, which is haldi, and ginger and also other herbs like garlic. Indians are very lucky to have this kind of food. In every food you should include ginger and lasun, and also herbs, powders, the chili powder and all the spices of Indian food should be included so that you can increase your immune system. Next. So, the trace elements that help increase immunity, as we have seen, is also zinc, selenium, Fe, potassium, sodium, calcium, magnesium, copper. So, what do I conclude with my talk is that trace elements are found in plenty in nature. It is left to us how to use it for our well-being and health. If we destroy these elements which God has given in the nature, or if we do not use them, we will end up in the hospital and our relatives will be worried about our health. So, trace elements, I through my technique I can help you diagnose what the problem is using by quantifying these trace elements in any sample. I have got a large number of work using this my technique. I have carried out in spices also, in bones I have carried out trace element studies, and if you go through go to Google and type my name Dr. Daisy Joseph BARC, you will get the list of publications and the collaborated work that I have carried out with so many universities in India. You name them and I have collaborated and carried out their work using my technique. The new technique which setup which I do have is a handheld XRF, which is like a gun. I have not included in my PPTs, but this can go to the place where you want to detect the elements, and it has been very, very useful. Recently, in collaboration with Andhra University, I have carried out analysis of marine fishes, which is an indicator of the toxicity in water. The fish that we eat should not contain any of the toxic element, which could happen because of the dumping of many water, sewage water and other water, which leads to toxicity, and fishes generally inhale this or consume this water, and marine fishes are an indicator of the toxicity in water. So, if you do have a problem, or if you want to see the element in any of the milk powder or any of the food which is consumed by everybody, you can always ring me up or contact me and get your samples analyzed, which is with the new setup that I have. For one sample I can analyze in 20 seconds. So, it is very easy to use, and interpretation of this spectrum can be done in a single day. So, I would recommend all the children that whenever you see the elements in any food or suspect anything, you do come to me and have a nice study of the periodic table of the elements. Every element has some role in our food consumption. Okay, thank you very much for your kind attention.